Welcome to Networks Professionals.
So today we're going to dive into something that sounds really simple, but is actually, deceptively complex. How do we measure if an AI is actually any good? We hear these huge performance numbers thrown around all the time, right? But as you're about to see, those numbers can hide a really dangerous secret, especially when the stakes are high. Let's just start with a question to get us thinking. What if I told you an AI system could be 99% right and at the same time be a complete and total failure? It sounds kind of like a riddle, doesn't it? Well, stick with me, because that's the exact paradox we're going to unravel today. So here's how we're going to break this down. First, we're going to expose what I like to call the accuracy illusion. Then we'll meet our two specialist metrics, precision and recall. After that, we'll get into the constant battle between them. And finally, we'll see how data scientists try to find that perfect balance. All right, part one, the accuracy illusion. And to make this really hit home, let's use a classic high-stakes example. Imagine a bank is building an AI to detect fraudulent credit card transactions. Now this, right here, this is the core of the problem. You see, in the real world, most data is pretty lopsided. For a bank, the vast majority of transactions, we're talking 99%, are totally legitimate. Fraud? That's a super rare event. This is what we call an imbalanced dataset, and it's exactly where our simplest metrics just completely fall apart. Now, when we want to measure performance, our first instinct, everybody's first instinct, is to reach for accuracy. I mean, it just makes sense, right? It's simply the number of times the AI was right divided by the total number of things it looked at. Simple, intuitive, and, as we're about to see, deeply flawed when your data isn't balanced. And boom, here's where the trap springs shut. Just imagine a very lazy AI, one that basically does nothing. It just sits there and labels every single transaction that comes through as legitimate. Well, because 99% of transactions are legitimate, this lazy AI gets a 99% accuracy score. It's right almost all the time, but it's completely useless because it fails at the one and only job it had to catch that critical 1% of fraud. That right there is the accuracy illusion. Okay, so clearly we need better tools for the job. More specialized tools. So let's meet our first specialist, a metric called precision. This one is all about understanding the cost of a false alarm. Precision asks a very specific and really important question. When my AI raises its hand and shouts fraud, how often is it actually right? Its entire focus is on the quality of those positive predictions, and it pretty much ignores everything else it might have missed along the way. So you can think of a high-precision model as a cautious specialist. Its main goal is to reduce what we call false positives. It absolutely hates being wrong and causing unnecessary trouble. A perfect example is your email spam filter. You'd be pretty furious if it started throwing important emails from your boss into the spam folder, right? That's a false positive, and spam filters are tuned for super high precision to avoid that exact thing from happening. But what if annoying a user isn't your biggest fear? What if your absolute biggest fear is letting a real threat just slip through the cracks? Well, for that, you need a totally different kind of specialist. And this is recall. Sometimes you'll hear it called sensitivity, and it just flips the question completely. It asks, of all the real, actual fraud that happened out there in the world, what percentage did my AI successfully catch? It's not worried about a few false alarms. Its only job is to find every single needle in that giant haystack. And this is why we call it the zealous guardian. Its absolute number one priority is to reduce false negatives. Those are the ones that get away. For our bank, a false negative is a fraudulent charge the AI totally misses and the customer ends up losing money. In medical screening, a false negative is a sick patient being told they're perfectly healthy. The consequences are massive, which is why recall is so incredibly critical in these fields. So now we've got our two specialists. Precision, the cautious specialist, and recall, the zealous guardian. But here's the catch. They are almost always in a direct tug of war. If you push to improve one, you'll often make the other one worse. Let's just put them side by side to make it really clear. Precision is obsessed with the accuracy of its alarms. It's terrified of false positives. But if it's too cautious, it's going to miss real threats. On the other hand, recall is obsessed with finding everything. It's terrified of false negatives. But if it casts its net way too wide, it's going to inevitably flag a bunch of innocent cases. You can really feel the tension there. It's this constant balancing act. So how in the world do you choose which one to prioritize? Well, the answer is always always in the context of the problem. For our bank, the choice is pretty clear. Missing a real case of fraud is usually much, much worse than, say, temporarily blocking a legitimate card by mistake. And this leads us to a really clear decision for this particular use case. We absolutely have to prioritize high recall. We're willing to accept a few more false alarms, which just means a slightly lower precision, as a trade-off for the security of catching as much real fraud as we possibly can. The context really does determine the strategy. But what if you can't just pick one? What if both false alarms and missed detections are just incredibly costly? Okay, let's move to our final section and see how we can resolve this tension. Meet the F1 score. Now, the term harmonic mean might sound a little technical, but the idea is actually super simple. It combines precision and recall into one single number. The really important part is that a harmonic mean heavily penalizes low scores. So a model can't cheat by having perfect precision but a terrible recall. To get a high F1 score, both of them have to be high. It's kind of the ultimate test of a well-balanced model. Okay, let's pull this all together with a quick little cheat sheet. Use accuracy for general correctness when you know your data is balanced. Use precision when false alarms are your biggest nightmare. Use recall when missing something is the ultimate danger. And you reach for the F1 score when you really need a single metric that represents a true, honest balance between the two. So the next time you see a headline that says new AI is 99% accurate, you'll know better. You'll know the first question to ask isn't how accurate is it, but accurate at what? And even more importantly, what are its precision and recall scores? Now you've got the tools to look past the hype and really understand what's going on under the hood.
Thanks for watching.